Yes, so welcome. Here is Johnny, and we have a special guest today again, Taz, known by the nickname Smart Contract Programmer. You probably already saw him on YouTube. He has a lot of awesome tutorials and videos, and also I interviewed him on my channel, so maybe you watch this one. If you didn't, check it out. Awesome tips and nice interview. So Taz and me just got in touch, I guess like 2 months, Taz, correct me if I'm wrong, 2-3 months ago, something like that. Yeah, and we decided to do cool stuff together because Taz got some free time, I got some free time, and we decided both to do the interview to show you who is the guy behind Smart Contract Programmer, all the awesome content that he publishes, and share his experience as smart contract developer for many years. And also to try to work together. Now, to be honest, I didn't do that many auditing contests before, and he neither. He did some bug bounties before, and we said, let's do an auditing contest together, and we picked the Ethereum Credit Guild on Code4Rena, so we can also do this live stream later and share our progress, how we worked as a team, like how we audited the code, what findings we submitted, what issues we submitted, the diagrams that we created, the audit comments that we wrote, how did we work together as a team? And we thought that it would be very valuable to share this thing that we actually tried for the first time. It was super fun and super insightful. I learned a lot. Also, I guess Taz enjoyed and learned a lot. And we got some interesting results also. And today we are here to share with you all the journey, all the process. So we will do many things, including we'll talk about Ethereum Credit Guild. What is this protocol? We'll do a quick overview of the protocol, the architecture, the smart contracts. We'll explain how they work. We have only 2 hours, it's a lot, 2 hours for this stream, but so we'll try to be to the point without like going deep dive too much into the contracts, but the main functionality, the main logic, we'll show you the diagrams that we created in order to understand the protocol better. And we will share how we worked, basically. How was our framework? How often did we meet? We will even show you, even maybe if Taz will allow, our Discord chats, like how we communicated, sometimes async. We also had like daily or like every 2 days, we had like sync calls of 1 or 2 hours where we like shared our ideas, our findings, did some brainstorming. And obviously, we'll show you the findings that we found, mainly Taz, to be honest. Taz found like some cool findings, but we shared like a lot of ideas together, and some of these findings came from these ideas. We reported, I think, how many findings? Like 3 highs, 2 lows, or maybe more. Let's see.
I think two or three mids and 2 or 3 highs.
2 or 3 mediums and 2 or 3 highs. And we think maybe 1 low, if I'm not wrong. Let's see. So if we go to Code4Rena now, I'm not sharing my screen yet, but I will share it in a second, so you will see everything. Don't worry about that. Where can we see the submissions? In the Code4Rena interface, can we see that? Maybe in the profile.
Or the same ones are also in our GitHub, for the private GitHub.
Yeah, we have our private GitHub. So we'll show you also our private GitHub. We basically we didn't fork the repository, but we just copied it, created our own repository, added our audit comments on top of that. We created issues there, every finding we had also an issue with all the ideas that we have. Once it became like a tangible issue, then we created an own issue with all the finding reports, the POC. Yeah, so it's going to be super cool. You know what? Let's start. I will share my screen right now. 1 second. Guys, please, for anyone that participated on the Ethereum Credit Guild Auditing Contest, please write me in the chat so we can see like how many people are already kind of familiar with the code base and the architecture. And also we will let you, of course, share your findings, because we are sure that there are more findings that we missed. And some of you might share some of the findings. I know I talked with Flint, which is very active on Twitter, by the way, sharing his progress. So this was the repo that we created, as you can see here. And here, basically, it's the same repo from the contest that we took from Code4Rena. But obviously, we have 2 branches over here, Johnny and Taz. So everyone had their own, we had our own branch. and we sometimes merge them into main. More like by the end of the contest, so we can see each other audit comments and merge them. But that's how we can see each other audit comments and work on them together. So we created a branch, and I wrote my audit comments, and Taz wrote his audit comments. By now, we should already be familiar with what are audit comments because you've been through the smart contract hacking course, and I understand that you already have some experience. So it's from the Visual Studio Solidity Developer extension that you can add these highlighted comments. And this was the repo, actually. Let's see on which branch. Yeah, right now I'm on main. I think I merged my last findings or audit comments to main. And this is how they look like. I just want to show you. So here in SRC, let's say governance, and let's do Veto. Guild Veto governance. So you see all these nice like highlighted comments, audit issue, audit okay. So these are all my audit comments. We also added our names, so we want a mix. So before an audit comment, I wrote Johnny, and Taz, Smart Contract Programmer, wrote Taz. So we know like who wrote which comment when we merge the code. And yeah, that's how we added comments along the code. When we work separately on the code. Let's check out two Taz brands, git checkout Taz. So git checkout, I need to commit status, git add, git commit, minus m, just a commit, it doesn't matter anymore. Git push, so I guess I just changed some files before and I didn't push them. And now I can do git checkout Taz. Cool. And now I'm supposed to see Taz comments, right? So if I want to see like what Taz did, or maybe he finds something interesting. So Taz was more focused on the loan contracts. So I can just do git checkout Taz and see what kind of comments he added. Okay. So you delete some of them, but by the way, you can use this kind of inline bookmark tab in VS Code. And as you can see here, you can open every file and see all the audit comments. Another cool tip, if you want all of them to be organized in some place, instead of searching them over all the files, you can just use this kind of nice toggle bar. So that's about audit comments, the GitHub repo. As you can see over here, these are the issues that we created in our repository. And later on, just before the contest end, we submitted them actually to Code4Rena. So we also marked them as low, medium, highs. We'll get to them later. But for now, I want to show you the framework, how we worked, how we collaborated as a team. So how did we divide the work? So as you know, if you participated in the contest, it's a pretty big code base. It's a pretty big code base. It was very interesting, but if you would ask me twice, maybe for this kind of live stream and for the time that I had to dedicate it for this contest, I would pick a smaller one because it was around 90K contest with around 4,000 lines of code. It was a lending system, which is quite complicated because they invented something quite new. If you've been through the course, through the lending protocols chapter and money market chapter, you know that we have Aave, we have Compound, and these protocols are using Oracle to fetch tokens price from the outside world because we don't know what is the token price, and they use sometimes Chainlink, sometimes Twap oracles. And these guys in Ethereum Credit Guild, they decided that they want to create a lending protocol without oracles. Now, how do you do that? Very good questions. That's why it's a very complicated protocol. And where you have complications, you usually have issues, which we were able to find some of them. But I'm sure there are more, for sure. And there was sometimes questions that I asked myself, like, is this actually going to work? Because how can you fetch the price? How is this protocol stable? And it was a very complex protocol. That's for sure. I guess if you participated, you felt the same. I would be happy to hear your feelings and your experience from the audit if you participated in. How was it for you? Is it a bit overwhelming? Maybe it was easy. Was it similar to other audits that you've done before or participated? feel free to write it in the chat. And since it's a big code base, we divided the work initially that everyone is focused on a different part of the protocol. So Taz was focused more on the loan contract, as you can see over here. I will zoom in. So Taz was focused here mainly on the loan contracts and also in the tokens contracts, because obviously the tokens are like the building blocks of all the protocol, right? So if we have the credit token and the guild token that are being used in loan and governance, then basically they use the token features that were defined and implemented inside the tokens contract. So both of us kind of like took a look at the tokens contract. Taz was focused on the loan contracts and I was focused more on the governance initially. Also, Taz had more time to dedicate to the contest. That's why obviously he got like he's been through these loan contracts which are much more complicated in my opinion. How also the profit manager, which is kind of like between the governance and the loan contract. We will see in a moment what every contract here means. And yeah, so this is how we did it in the beginning. And meanwhile we read the contracts, we obviously added our audit comments. I will check out back to the main branch, so you will see my comments. It will be easier for me to explain. And yeah, so I basically started by going through the governance contract, like the guild governor, the time lock, the veto, the onboarding, offboarding. But another thing that we did is prior to the contest, before it actually started, you could find the documentation of the protocol. So I read the documentation, and also you could actually find the actual GitHub repository with the code that is going to be in Code4Rena, because they froze the code 1 or 2 weeks before they actually started the contest and it was available. So if you had more time, you could dedicate it to this contest before it actually started, and you might have an edge on other contesters. Unfortunately, I didn't have much time, and I think Taz neither, so we didn't took this advantage and use it for our edge, for our advantage, but it was possible. I just one day before the contest read the docs and read about the governance and about the protocol a little bit. It's a bit overwhelming, obviously, because it's a lot of new concepts. Some of them are familiar, some of them are less familiar. But if you feel this overwhelming feeling in the beginning, there is so much code, it's such a big protocol, just know that you're not alone. Every single auditor have this same feeling. The start is the hardest because really you're just diving into 4,000 line of code for other developer. You need to get into his mindset. You need to learn a new protocol, new technology also. It's not just a fork of another protocol. It's a new technology. They invented something new and it's not simple. So just, be positive about it and know that every other contester is going through the same thing. You just need to have some edge. That's it. And keep going. So this is my tip and how I felt in the beginning. By the way, another disclaimer, you cannot do it, actually, what we're doing right now in Code4Rena. You cannot participate in auditing contest and show your findings to the public, either if it's like YouTube, Twitter, Discord. You should not tell it to people before the audit report is published unless you get a written approval from the sponsor, which I have. So the sponsor of this contest, which was a great guy, by the way, helped a lot, not only to me, to many people. He was very responsive. This guy, Iswak, very nice guy, very helpful, and he approved this live stream. And so just so you know, if you have any findings, you're not allowed to show them on Twitter or something before the report is published. Another FYI. This one you can because the sponsor approved. Nice. Another thing that I wanted to do before we start talking about the protocol, to show you our diagrams and the meetings. So basically we had almost every day or every 2 days, we had a meeting where we just met just like that on Discord. And we shared what we learned, if we have any directions, how is it going. In the beginning, it was more like short meetings. It was just short updates, like up to 30 minutes. Yeah, I went through this, I went through that. We asked questions to each other if we didn't understand anything. Maybe we assigned some tasks to each other. And the more time passed through the contest, These meetings became longer because we had to brainstorm some ideas, to think about attack ideas, or maybe I had an issue with a POC and Taz tried to help me, or we had a direction for a finding for an issue, and then we tried to think about it together. So this is how it was. And in the beginning, we just started learning the protocol and drawing these diagrams. So as you can see, we have a lot of diagrams, so many diagrams that we had to split them into 2 Excalibur files. And both of us basically drew diagrams. So meanwhile, I went through the governance contract. As you can see, I basically, actually from the part where I started going through the docs. So I draw these diagrams, okay? So you can see here, there is a process where you can add new lending terms to the protocol. And this is something that I read from the docs. And I just summarized it as like a flow chart here in Excalibur. So we have propose, we have the vote, and this takes 2 days. Then there could be a veto for this lending term, so people can block it from happening. And yeah, so just chart flows. And this is already when I got into the smart contracts and I started drawing like every function, what happens. So create term, the user calls this contract. Then these are the validations that are happening. Maybe there are some missing validations, right? Maybe some of the parameters are not being validated. Maybe we can manipulate the state somehow. Then we create a new clone. Then we initialize the clone. So they use Open Zeppelin minimal proxies, clones. So this is how these diagrams work. You see, we basically break down every contract, every functionality to diagrams so we can understand them better. And also when we forgot something, we can always go back to these diagrams and see how it works. Also, if you want to come up with attack ideas, we can, instead of going and looking at the code, we can just look at these diagrams and try to think, what if we call this function? And then before step 3 happens, we call this function, or maybe with this callback, we call this function. So it's a very nice way for you to understand the protocol while being active at the same time. For me, I'm an active learner, so I'm learning more by doing. You already know that. I talk about it in the course. I talk about it on YouTube. So if I will just read the code, just another tip from me, if I'm just reading the code, just scrolling, I'm going to have a blackout. I'm not going to be focused. I'm not going to be like, it's just not going to work for me. I'm going to be very slow and I'm not going to consume the information good enough. So what helps me is first writing these audit comments, not only audit issues, but explaining myself the protocol. So if I read a constructor and I have something to say, I will write it. If the constructor looks okay, I will add a comment here, audit, okay, looks good, or nothing to see here. And then I will fall it down over here and move on to the next function, okay? Try to go function by function until I understand all the protocol. And another way to learn the protocol better is not only to read the functions, but create these kind of flow charts so you're actively doing something, not just reading code. And then it's also helpful resource for you or for the other team member that you are working with. Taz, do you want to share any tips that helped you while getting familiar with the protocol, while creating the diagrams, or anything that you want to say?
Take a break when you're tired, and maybe also sit in a place where there's little distractions so you can focus. So I think like the max, I think I was like focused for like 1 or 2 hours, and then I would take like 2 hours break and then do the same thing again.
Funny that you say that. I tried Promodoro because there was a huge hype on Twitter about this, and a lot of jokes. It didn't work very well for me, to be honest, this Promodoro method. But then I just went back to my actual method, which is like using the calendar. So I just put on my calendar just, what I'm working on right now, and then I get a reminder, and also like it when it's organized. So I put like block of 1 hour, review this contract, or 2 hours, try to write POC, 3 hours, review this contract, 1 hour, submit this finding. This is like, I put my tasks in the calendar as time blocks, and that's what helps me get things done. So that's another tip on my end. Another disclaimer, it was hard for me to focus in this contest in particular because I just moved to Thailand and I saw a lot of friends that I haven't seen for a long time that lived with me and worked with me in Singapore. And I don't know if you are from Europe and the first time that you see like incredible views and like beaches and like just, like amazing views. So yeah, it was a bit hard to go back to the screen and to the code, but I did my best. So yeah, it was a bit hard, challenging to focus, but you find your ways, everyone with his own ways. Taz shared his tips. These are my tips. So protocol overview. So Ethereum Credit Guild is a lending protocol that works very differently than any other lending protocol that you know, aka Aave Compound. There are no oracles and the governance playing a much bigger role than in other lending protocols. How does it work? So first thing is that we have the guild token. The guild token is kind of, I would say, the most important token. The guild token is the governance token. Like in Aave, you have the Aave token. In like Uniswap, you have Unit token. So this is the guild token, but it has a lot of things that you can do with this guild token, more than just vote for proposals. You can do other things. You can stake it and make yield. You can be slashed if you staked your guild token in some kind of lending term that had bad debt. And there are a lot of like interesting nuances around this guild token. What else? And it's not transferable. So initially, it's not going to be transferable. You can earn it from the protocol when you stake credit token, which we'll talk in a moment. What are credit tokens? So this guild token can be minted for you. You can vote for stuff on the protocol, for proposals, for lending terms. We'll understand in a second what this lending term means. You can stake this guild token to make returns and interest, to accrue interest. But you cannot sell it. Initially, you cannot transfer it to another wallet. It's not transferable unless the governance decided it is transferable. You cannot sell it. It won't have liquidity probably in the beginning. So this is a guild token. But obviously in the future, it will be transferable. It will have liquidity. Now, what is this? Before that, the guild token is implementing multi-votes and gauges. Gauge. I don't know how to say it. Everyone says it differently. But gauge or gauge is something like curve protocol, where like gauge, you can imagine a gauge where you can put your guild tokens inside. And this is how basically the gauge is being filled and a more liquidity is getting allocated. Something like that. So in curve, when you vote for liquidity pairs, right? Basically, the more the gauge is full in curve, this liquidity pair will have more curve token yields, right? More farm yields, so basically, a lot of protocols have incentives to get curve tokens to vote for their liquidity pair or try. It could be like 3 tokens in one liquidity contract. So basically, protocols have incentives to hold the curve token, because using this curve token, you can vote for gauge and increase the yield rewards. And basically incentivize more people to add liquidity to your token or your protocol. So gauges are being used here to vote for lending terms, not for like liquidity contracts or liquidity gauges like in curve, but for lending terms. Now, what are lending terms? I think before we talk about the governance, let's explain a bit what are lending terms.
Lending term, it's as the name suggests, you're able to lend, you're able to deposit collateral and wait. Can you go over to the right? I think
to the right.
You should start with the mechanism. There's an example of deposit ETH collateral and borrow USDC.
This one?
Yeah. So this is ECG is a lending protocol, and the way it works is, you need two sides: users that will supply the token and users that will borrow the token. For the supply side, users would deposit some kind of token. Initially, they said they're just going to launch with USDC. So they deposit USDC in a contract called Simple PSM. And this would give the user back a credit token. In this case, it's called GUSDC. For each token that they deposit into the Simple PSM, they get a different credit token. So you might have like GUSDC. If you deposit USDT, then if you deposit USDT into a Simple PSM that supports USDT, then you will get something like a GUSDT. But for now, they only have support for USDC. So yeah, once user gets credit, GUSDC. Next is the borrow side. How would you borrow USDC? A person that wants to borrow USDC will first have to deposit collateral into a lending term. The way, parameters on like how much collateral you need to deposit in order to borrow a certain amount of GUSDC is set by the governance, and it is fixed inside the lending term.
1 second, I will just open it to show.
Yeah.
So we have the borrow function.
Yeah.
And as you can see here, we have a calculation of max borrow, which is dependent on the collateral that you put in ETH and some kind of parameter that this lending term is being set up with, created with, divided by credit multiplier, which is like the secret sauce for this whole protocol and the Pandora box for this whole protocol that we will talk about later. But basically, we determine how many credit tokens you can get based on your collateral and these parameters. Yeah.
Okay, so user deposits ETH as collateral. They will get back GUSDC as credit. Now the user wants to borrow USDC, so the way it works is he would take this USDC, put it into Simple PSM, and Simple PSM will give the user back USDC.
Yeah.
I think that sort of explains how lending and borrowing works and also explains the lending term.
Yeah, that's great. That's great. Any questions, guys, so far? How the protocol works? About how lending works, like the flow of like how you supply USDC, get GUSDC, deposit ETH to borrow credit tokens. So this GUSDC and maybe in the future GUSDT or other tokens is also called credit token. So in tokens here, we have here credit token, which initially going to be only GUSDC. But again, it could be GETH, GUSDT. And another thing about Simple PSM, PSM stands for Peg Stability Manager, which means that this is the contract that model, yeah. And this is the contract that is, Peg Stability Module. And this contract is basically responsible on the fact that this GUSDC will be pegged to USDC. So if USDC is $1, it will be $1. So if there is ETH and GETH will be 1-to-1 with ETH. That's why it's called Peg Stability Module. And that's how it works. So that's about how Simple PSM work. You can deposit and redeem the collateral token and get or burn the credit token, mint or burn the credit token. That's what it does, just minting and redeeming, deposit and redeem, mint and burn. And the credit, so this is the credit token, right? So that's what we talk about, the credit token. The credit token is also a rebase token. Do you want to explain what does it mean, Taz?
I'm not really sure, but it's something about the total supply of tokens keeps changing over time. The way it works inside this credit token is that every time there's some kind of profit or loss, it targets a different total supply, and over time the total supply moves towards that target.
Exactly. So why it's important? Because these credit tokens accrue interest or yield, right? But their value is always supposed to be tied to the collateral token. So you might ask, how is this yield or interest being paid to the lenders? How is it being paid? By rebasing. Rebasing means that if you hold 100 GUSDC tokens and these GUSDC tokens are staked or landed somewhere, the more time passes, you will get your 5% APR or APY, your interest or your staking yield. You will get it as in a form of more GUSDC tokens. The GUSDC token value will not go up in price, but you will get more GUSDC tokens. Your balance will increase over time. That's what rebasing means. And if you're familiar with Wonderland Time and Olympus DAO protocol, I think they were like the first ones that introduced rebasing tokens, or maybe there were other protocols that did before, but this was like the big protocols back then in DeFi summer 2020, 2021. So this is rebasing. That's simply what rebasing means. That basically you have more and more tokens in your balance, and this is how you get interest or yield farming, staking yields. So that's what it means. So what's important to remember and understand is that this credit token is a rebase distributor token. Is that clear so far? And the guild token is gauges and multi-votes. Yeah. So these are the tokens that we have in the system. We have the governance token and this credit token. We already talked about lending term and simple PSM. Simple PSM make sure that the credit token is pegged to the collateral, and the lending term is a bit more complicated. This one is actually the logic of the lending term, but there could be a lot of lending term deployed using minimal proxies, clones in OpenZeppelin. So there could be one lending term like you saw over here that you deposit ETH and you get X GUSDC for it. There could be another lending term that you deposit ETH and you get less GUSDT for it, or more GUSDC for it with different parameters. It could be with different collateral token. Maybe the collateral token would be wrap BTC and you would get GUSDT. So every lending term has same code, same logic, but different parameters. So you're going to deploy the same smart contract, this one lending term .sol, but the parameters will basically say which collateral token is being deposited, which credit token is being minted, and other parameters like what is the ratio between them, how many credit tokens you could get per each collateral token, or other parameters that we won't get into right now, only when we'll get into the findings because they have some issues. So these are references, but these are parameters. All these parameters will determine the lending term. Like what is the collateral token? What is the max debt per collateral token? How many can you get credits for every collateral that you deposit? The interest rate that you have to pay and the credit holders are receiving. Minimum partial repay percent, opening fee, hard cap. Yeah, so these are all the parameters of a lending term. Now, how new lending terms are being introduced to the protocol? Using the governance. Okay, so we have this contract called lending term onboarding, which basically means that but guild token holders, the governance token holders, can propose a new lending term to the protocol. Right? So I want to propose so that someone can deposit wrap BTC, and for every wrap BTC that he deposits, he can borrow 20,000 GUSDC tokens. I can do that if I have guild tokens. I can make a proposal over here. I can go here to create term. The implementation is this smart contract. This one, lending term.sol. And it should be in whitelist of implementations. So this is another thing, like as you can see here, I added here audit. Okay, what if I will put a malicious implementation? No, it needs to be here in the mapping of implementations. You cannot just pass any arbitrary address. And here are the params. So these params are the exact same params that we see over here in the struct. We set them here when we basically create a new term. Once we created a new term, we are proposing it. So this propose is basically disabled because they are inheriting the OpenZeppelin governance smart contract. So they they had to override this one. They prepared this one instead, propose on board, which is like dedicated to the specific proposal to announce a new lending term. So I will go back to the diagrams. It will be easier to understand. As you can see over here. So first you call, I think I did it. First you call create term, basically. Then we call propose on board. Okay. And if you got enough votes, which means that a lot of guild token holders support these proposals and they want this lending term, then that's what happens. This proposal is being prepared, as you can see. And this proposal is actually creating this contract is actually gonna onboard this new lending term to the protocol, and then people can use it and they can basically start using it, right? But that's not enough, because if you remember this diagram that I drew when I read the docs, you have 2 days to vote on the proposal. Now, let's assume that it passed, which means that 1% of the guild supply need to vote for it. 10 million guild token holders need to vote for it. Not holders, but need to vote, like 10 million guild vote yes. Then you have 1 day of veto. What does veto means? Maybe there are another 10 million guild holders that don't want this lending term. They can veto your proposal. So if I don't like this lending term, I can just create a veto. So during this 1 day, this new proposal goes to a time lock. It's not going to be added automatically. It's going to be here inside guild time lock controller. So it's like an action that was passed. It passed this initial voting, but it's not executed yet because we need to wait 1 more day to see if someone wants to veto this proposal, right? Makes sense. So it's going to be added to the time lock of 1 day. And then we have this contract that's called Guild Veto Governor, where people can create proposal to veto pending lending terms. So once it's in the time lock, we can create another veto proposal to say, we don't want this lending term. We want to remove it from the time lock. And that's exactly what it does. So we can create a new veto. And if we have enough votes, 10 million votes, 1% of the supply, you can see what happens. The veto is simply just, let's see where it is, get veto calls. It just to remove, as you can see, cancel the operation from the time lock contract. So if the veto passed, we just remove it from the time lock contract, and this onboarding is gonna go to trash, this onboarding proposal. So lending term onboarding, is that clear? Any questions? How we onboard new lending terms to the protocol? No, there is no downvote, guys. There is only one vote. There is no yes or no, but just to support a proposal. So if there is a new lending term, we want to propose it, we just support this new lending term. And if we vote for a veto proposal, we just support to kick out this new lending term that is being proposed. And we have some questions here. So A tokens equals G tokens, deb tokens equals debit tokens. Yeah, something like that. Not always, it's not hard coded. We have another parameter called Credit Guild that he can break this peg, but we'll talk about it later because there are some interesting findings over there. So, okay. What if we have a new lending term that is making problems, right? So maybe we created a new lending term like deposit ETH and get 1,500 GUSDC tokens for this ETH. And then what happened to ETH? It dropped in price significantly. So let's say now ETH is $3,000. So when we created this term, we said, okay, for every ETH that you deposit, you can get 1,500 GUSDC tokens because it's over collateralized. You can get 50% of what you deposited. Then the next week, ETH dropped to $1,000. People can still deposit to this lending term 1 ETH and get 1,500 GUSDC tokens. This is bad, right? Because it's going to create a lot of bad debt. And remember, we don't have oracles in this protocol. So when there is volatility of the collateral token like ETH, or maybe even with the credit token, because the credit multiplier is being changed, we'll talk about it later, this lending term might be problematic and the protocol and users might lose money. That's when we want to offboard problematic lending term. So in case what I described just happened and this lending term is bad, the governance can create a proposal to offboard a lending term. Now, because it's time sensitive, because at any time the protocol is losing money, we don't have a time lock when it comes to removing a lending term from the protocol. It just, when it passes 10 million votes, That's it. It's gone. It's being deprecated and no one can use it anymore. And then you have more questions. What's happening with open positions? What happens with liquidations? What happened with all the people who deposited ETH? Where does it go? What happens with all the people that have USDC tokens and they stake them somewhere? So it's a lot of complexity that happens behind the scenes, and that's where the bugs hide. So this is regarding how we offboard the link term, and we have these smart contracts, and we have also these diagrams over here. Sorry, this one. How it works. Let's look at the smart contracts. It will be easier. So first we propose offboard. We say we want to offboard this lending term ABC, right? Then people can support this offboard. They can vote for it over here. So anyone with a guild token can support this vote for it. And if we got quorum, which is 10 million tokens, then we can call offboard, and then automatically it's being removed. Now, between offboard, we have some time that something happens, and then we call another function called cleanup. So remember that I told you that, okay, you offboarded a lending term, but what about all the open positions, about all the liquidations, about everything that happens inside? You cannot just remove it directly from the system. You need to do some stuff to make sure things don't break, that people don't lose their money. That's exactly what happens between the offboard and the cleanup. Only when all these loans are being closed and all the money was returned and everything was liquidated or got forgived, or we forgive the open loans, that's when we call the cleanup, and then we completely remove this lending term from the system. Yeah, so this is, long story short, how the governance of this protocol works. And before we move on, I want to ask you if there are any questions. There is a room for malicious lending term, but the implementation needs to be in the whitelist. It's going to not be just a random smart contract that you created or an EOA account. And also, the parameters will be seen and people will not vote for it. So if you will just propose a shitty lending term or something to gain value from the system, the guild token holders will not vote for it. Taz, do you want to explain a bit about the auction house, about liquidations, about the staking also, before we get into the findings?
Okay. Can you go over to Excalibur loan diagram? And
Sure.
I think the best one will be the one about tokenomics. So if you have gauge guild tokens, you can vote for lending terms. This will increase the weight of the lending term, which means that lending term will be able to borrow more tokens. The way the user can get the lending term. So this explains like the whole tokenomics. We have a user. Let's say that he has credit tokens. One way to get this is to stake your USDC inside the simple PSM, and you can get credit tokens. So a user has credit tokens. If he wants guild tokens, he would stake his credit tokens into a contract called Surplus Guild Minter. Surplus Guild Minter will, over time, assuming that the lending term is doing well, will give the user back more guild tokens. So that's step number one. Step number two, increase gauge rate. So once they have guild tokens, they can increase gauge rate. This means they're voting for a lending term to increase the borrowing capacity of a lending term. And this will take them to number three, increase debt ceiling on the lending term. So when you increase the debt ceiling, this means that more users will be able to borrow credit tokens from this lending term. So this also means that this lending term will generate more profit. The profit will be reported to the profit manager contract. And the profit manager will report back the credit to the user. And the user, since now has more credit, they can repeat the cycle to get more guild token and get more credit. So I think that this explains how like the tokenomics work in ECG.
This is a beautiful diagram. Only smart contract programmer can draw such awesome diagrams, really. Like so simple diagram that explains the whole idea of the protocol. I love it. So yeah, you can stake both credit and guild tokens. You get the credit tokens with the simple PSM. This is one way to get credit token. The other way is to to mint them by depositing the peg token like USDC. You get USDC, or through other active lending term where you can provide collateral and get credit tokens. Then you stake them, then you get guild, and with the guild, you can also vote for proposals. This is one, but another thing that you can do with your guild token, you can actually stake it for a lending term. So if there is a lending term that you like, you can support this lending term. So this is what Taz said, you can stake those guild tokens to the lending term. And what happens when you do that is both people can borrow more using this lending term. So it means that more rewards will be generated for you, for the stakers that staked for this lending term, but you can also get slashed, which is something that is not described in this diagram, maybe in another diagram. So if this particular lending term that you staked your guild token for has some losses, then your guild tokens, all the guild tokens that you staked for this lending term is going to be disappeared and burned and slashed to cover for the fact that this lending term lost money. So this is how the system works and how they incentivize to borrowing and lending and guild holders to stake and support lending terms, and how gauges work. So when you basically deposit guild token, the gauge is increased, so it's being filled and more people can borrow money from this lending term. And it's a very complex system, but when you create this diagram, it really helps breaking it down. And I think, correct me if I'm wrong, Taz, only like 4 or 5 days later, you mainly came to the point and you told me like, okay, I understand the system, right? It took us like a while to understand like how it works.
Yeah. It's only like the last few days that it really clicked.
And then even the last few days, you still have questions mark of like, okay, how does this work? Like what happens if this? And it was a very interesting system and complex one, but hopefully with this explanation, you're able to understand it a bit better. So this is the surplus.
There's another.
Yeah.
There's another thing that maybe we should explain, and it's how collaterals are liquidated and what are the conditions for liquidation.
Yes, sure. You want to explain that?
Yeah, there's a diagram somewhere on the right with the price and to the left a little bit.
This one, AuctionHouse.
Yeah, you can probably start there.
Okay, which call?
Yeah, inside AuctionHouse.
You don't want to start with call in lending term?
Okay, we can start here. So let's say that a user put in collateral, borrow credit. Now this user's loan can be liquidated under I think 2 conditions, whether the gauge was deprecated or not. And the other condition is that the borrower has not paid a partial amount of the loan. There's a time limit before the borrower has to do a partial repay on his loan. And if that time limit expires, then his loan and collateral can be liquidated. So this is called call, and anyone will be able to call a loan to get liquidated. And this would, when liquidation starts, it would go over to the auction house. And the way the auction works is a Dutch auction. So you start auction and then go down. It will call the function. Users will be able to call the function bid. And then when the user calls bid, it will go back to the lending term contract to call on bid and does some calls to other contracts. I think the interesting part was that if you go over to the right a little bit, how the collateral is priced without an oracle, and it's done by Dutch auction. So remember that one of the conditions for the loan to get liquidated is that the user has not done a partial repayment. In that case, it will go to the auction house. And the way the pricing for the collateral is determined is that we do a Dutch auction first. So there's three points in the auction. Liquidation start. When it starts, the bidder will receive 0 collateral and he'll have to pay all of the debt. Over time, to the midpoint, the amount of collateral that the bidder will receive will become 100%. And at the midpoint, after the midpoint, the amount of collateral that the bidder will receive is 100%, and also the amount of loan that he has to pay will decrease over time, so that at the end of the auction, he'll be able to get the collateral, 100% of the collateral for almost no debt. But I did think that there was a condition that you cannot actually the loan free. So before the auction expires, he'll be able to get 100% of the collateral for almost free.
Yeah.
So this is how the price of collateral is determined.
It's very interesting and very good explanation, Taz. Thanks. Basically, there is once someone calls bid, that's it, the auction is done. But you don't have incentive to call bid in the beginning of the auction because you will just pay all the debt and get very little amount of collateral. So when, let's say, at this point it becomes profitable, then you will call bid and you will get a collateral and pay the debt. Here, if no one called until now, then it's probably very profitable. So you can call this, you can basically call the build function and get a very discounted collateral because you pay less of the debt and you get all the collateral. So yeah, it's a very interesting pricing. And as you can see, this is just an example of market price that because the collateral is obviously moving, right? Compared to the debt. The tokens are moving like ETH and GUSDC. ETH moves in price. GUSDC might also move in price if the peg is being broken. So there are a lot of parameters that are changing, and this is how the pricing happens. Another interesting thing that is different from other lending protocols is what parameters define whether a position can be liquidated. Because in Aave, if you remember from the classes, we have loan to value. Let's say we deposited 100K, we borrowed 50K, then our loan to value is 50% because we borrowed 50% of what we deposited. And what we deposited might move in price and what we borrowed might move in price. So this loan to value is moving. And once it gets to liquidation threshold, let's say what happens when your loan to value is 80%, this could be your liquidation threshold, that's where you can be liquidated. That's how it works in Aave and Compound, and how they know the ratio between the assets is using oracles. Here, they don't have oracles, so they don't know what is the ratio between the collateral token that you deposited to the credit token that you got. So the way they determine whether a position can be liquidated or not is what was the last time that you repaid some of your debt. So there is like a minimum repayment, which could be 30 days, 40 days, 90 days. And if you didn't pay even a little bit, and there is also minimum repayment. For example, 10% of your debt, you have to pay no later than 60 days. So if 60 days passed and you didn't pay 10% of your debt, you can get liquidated. This is just an example. Depends on the parameters of the protocol, of the lending term. And that's how it works. This is one criteria to get liquidated. The other one is when a lending term is being deprecated. The lending term equals gauge. This lending term is bad. It creates bad debt because the collateral token moved too much. Then the guild tokens, the governance is voting to off-board this lending term. And when it's getting off-boarded, then all the positions can get liquidated. That's how it happens. So it's completely different than any other lending protocols that you are familiar with, both the criteria, whether a position can be liquidated, and also how it's being priced. So there are a lot of new concepts that I've never seen in any other protocols, and that's what makes this new, interesting, but also a bit complicated. A borrower can also bid on their own debt to retrieve their collateral. Yes, anyone can participate in the auction. Anyone can bid, obviously. There is no way actually to limit it, right? Because you can also create another EOA account or another smart contract and bid for your own collateral. The idea here that anyone can bid on any liquidation. Okay, let me explain a bit about the profit and loss of lending term. So, what happens? A lending term can either lose or earn money. When it earns money, when the collateral token is quite stable, and also lenders are paying back their loan on time, and when the interest is nice, so it accrues interest, that's when a lending term makes a profit, right? We also have lending term that makes loss. How will it make loss? Because people didn't pay their loan, it got liquidated, and then people got it in a discount, right? So they got more credit tokens and paid less collateral token. This is one way that a lending term can lose money. Another way is that the collateral token is too volatile, or the parameters, the maxed borrow per collateral tokens is too high. That's when a lending term can lose money. So basically, these profit and losses are being distributed or deducted from the guild tokens stakers that staked for this lending term, right? We said it before. So if you stake a guild token for a lending term, you basically put your money, put skin in the game, then you can either lose money or earn money, right? You can either earn rewards in form of guild tokens and credit tokens, or you can lose all the staked guild or credit tokens, which is also called slashing, when there is a bad debt. So how does this profit distribution happens? I think it starts from lending term and NotifyPnl. Yeah. So as you can see here, NotifyPnl, we have the profit manager, which basically manage both the profits and the losses, right? Taz, correct me if I'm wrong, I don't remember.
Yeah, I think so.
Yeah, so he basically handles both the profits and the losses. He can mint and burn guild tokens, and he also holds some credit tokens, which he sends to as profit to people who staked, I think. Let's see.
Staked into the surplus guild minter, I think.
Surplus guild minter. Yeah.
You stake your credit tokens, you get back guild tokens in return if the lending term is profit. If there was a loss, I think you get slashed both for the credit and the guild tokens.
Cool. So this is the stake function in Surplus Guild Minter, where you select the lending term and you put your amount of credit tokens that you want to stake. And yeah, a lot of things happens inside, and a new user stake struct is being created, added to the stakes mapping. And this is how you basically support the lending term and can get also reward. You can also unstake your money, and there is a get rewards function. And all the reward calculation is based on this profit manager. So the lending term, every time someone closes a position, repay a position, it could be a liquidation, it could be a repay, then we call this NotifyPnl function, this one, in this profit manager contract. As you can see, there are like 5 places where we call this function. So one of them is in the repay function when someone is repaying his loan. We have another one in forgive. Forgive is basically when there is an open loan and the gauge was deprecated, the lending term was deprecated. As you can see here, there is access control. So the governor can call this function to forgive, and that's where we will have a loss of obviously for the lending term. It also happens here in on bid. On bid, if you remember, when auction happens, a position is being liquidated and someone is bidding on it, then we need to notify the profit and loss to the profit manager, because we either lost money or earned money based on the liquidation point where it was liquidated, and also in partially repay. Yeah, so you can either repay all your payment and then your position will be closed, or you can repay partially some of it. Oh, and this is also a good time to talk about this add collateral, which I reported as a low issue. You can call this function add collateral, which basically adds collateral to your position, but there is no incentive to call this function because if you remember, the only criteria if you are getting liquidated is if either the partial repayment time passed and you didn't repay partially of your loan, or the lending term got deprecated. There is no mechanism to check the value, the ratio between your collateral deposited to the credit tokens that you borrowed from the lending term. So basically, there is no incentive for users to add collateral because it's not going to affect whether you're going to get liquidated or not. So this function, they want to incentivize people to add collateral, but they are not incentivized because it won't help the user in anyhow. It's just going to risk more money for the user. So this was a low submission that we submitted, and we already covered one of the lows.
It's also to mention, you should mention that when a user calls borrow, it requires you to deposit collateral as well.
Yes.
So there's no use for the function add collateral.
Yeah, there is no incentive to add collateral for an open position, just to repay your credit tokens that you borrowed. So that's how it works. Let's see if there are any questions. Yeah, Profit Manager, both mint tokens and hold tokens. Yeah, both. So basically, we already understand that lending term is calling Profit Manager. There is this NotifyPnl function that could either receive it. As you can see, it's interesting because it doesn't receive uint, but int. Because int, the amount can be either minus or plus. If it's a minus, it means it's a loss. If it's a plus, it's a profit. And that's how it works. Now, you want to explain a bit how slashing happens and what is surplus buffer, because it will be relevant for the findings, I guess, right?
I'll explain a little bit. I think it will make more sense when we talk about the actual findings.
Okay.
Surplus buffer and terms surplus buffer, I think they are incremented when a user stakes credit into surplus guild minter. It will call into Profit Manager, pull the credit tokens into the Profit Manager, and it will keep account of how much credit tokens came in. So that's surplus buffer and term surplus buffer.
So this Profit Manager contract is, just to clarify, this Profit Manager contract holds credit tokens in balance. It's a contract that holds these tokens. Yeah, sorry, go
on. And stakers of surplus guild minter will get they'll get slashed if this notify PNL reports a loss.
Yeah, so if this amount is minus, as you can see here, if it's lower than 0, we notify gauge loss.
Yeah,
it causes notify gauge loss, and as you can see here, if it's 0, there is a lot of if statements here, a lot of things happening, but long story short, you get slashed, right? If there is a loss, you get slashed with your credit tokens and your guild tokens, and if it's a profit, as you can see here, amount is greater than 0, it transfers some credit tokens that it holds to the recipients, right? To the stakers, and also it means, right? Oh, it doesn't mean guild. I think, sorry. This one means guild tokens in get rewards function. Yeah. So here also when there is so basically Profit Manager is tracking the profits, and through surplus guild minter, you can call the get rewards to get those rewards, either in the form of guild tokens or credit tokens. So that's how it works. And you can also get slashed in your stake. Yeah. Questions? Okay, I think we can jump to the findings and we can start presenting the findings. And maybe also some students here also have some interesting findings to present. So let's start with which one, Taz?
We can start with the easy one, which will be probably credit token transfer to self. The cause basically, when you transfer credit token to yourself, it creates 2 copies of your shares inside memory. And then later on, it updates those two positions. But because you copied 2 of the same thing, the first write updates it correctly, and the second write overwrites the first one and makes it incorrect. As a result, you get more shares than what you had before, so you're able to claim more tokens. I think if you click on the code, they'll be able to see which part has the problems. So yeah, transfer and transfer from, they both have the same problem. You can imagine that if from is equal to 2, if they're the same address, then it will copy the same things. And yeah, and the first part, inside line 660, it would update the shares correctly. Now if you scroll down a little bit more, on line 600, what is it, 82, is it?
Yeah.
Yep, I think, yeah, well, this is from, so 697. Need to go to 697.
Mm-hmm.
Yeah, inside here, we're updating the shares for the account that is receiving the tokens, but since the receiver and the sender is the same, we're basically overriding the sender's account, and in the consequence, it increases the shares of the sender.
Super cool. So as I explained before, the credit token is a rebasing token, and we can transfer it from one account to another. And what rebasing token means that the more time passes, you get more credit tokens based on the profit. If your lending term made a profit, if your credit token made a profit, you get more profits. How it happens? Every time you call transfer or transfer from, this whole calculation of how much profit you're supposed to get is being executed. And there is a logic error which allows you to get more credit tokens if you just repeat this transfer operation from and to is the same. You just get more and more credit tokens, which is a very critical bug, I guess. Why did we report it as? It's a high, yeah, not medium.
Yeah.
Yeah, so it's a high, and yeah.
But you need to the number of shares that you transfer has to be low enough that you'll actually be able to claim the rewards. If you put it too high, then it would try to give you a lot of rewards, but because there's no rewards inside the credit token contract, it will just overflow.
Yeah. So it will. This is based on the fact that there are some rewards that are generated. You can just steal them from all the other users. So there are many users that stake for this lending term, and they are supposed to get these rewards, but you just steal all the rewards from them by just calling this transfer or transfer from to yourself. And that's the first bug. It's critical.
It also blocks other users from transferring their token because the transfer from logic calculates rewards for each user. But if they cannot receive sufficient rewards, then the function would just revert.
So it's both also the denial of service attack in a way, because you mess up with the rewards and the accounting, you screw up other users because these calculations happens anytime a transfer or transfer form is happening. So yeah, it's a pretty critical one. And as you can see, we reported it as high, and also Taz wrote a nice POC over here that demonstrates the bug. Do you want to explain a bit about the POC?
It just shows that user zero claims user zero keeps transferring tokens to self, and it prints out that he gets more rewards than what he's supposed to get.
Yeah, so basically just demonstrate the vulnerability, how one user just transfer tokens to himself and steal the rewards from other users. And we have One is this is the transfer function. So we try to transfer to message sender to ourselves, and this is the transfer from function where we basically the from and to parameters are the same, and that's how it works. And this was the bug. Anyone else was able to find this bug? And okay, so let's start with this one. Guild token Frontrun NotifyPnl to earn rewards. Gauge weights can be increased and decreased at any time without any restrictions, assuming no slashing happens. This can be exploited to earn rewards by simply Frontrun profitmanager.notifyPnl anytime there is new profits coming to the system. Furthermore, users can Frontrun and NotifyPnl to avoid slashing before a loss is reported. So if you just monitor the mempool and you see every time prof NotifyPnl is being called, if it's with a minus value, you can just unstake your tokens and avoid slashing. And if it's a plus value, like profit coming in, you can just front run it and just stake the tokens, get a profit, get the rewards, and unstake them right after. So you don't have any exposures, you just claim the profits and run away. That's basically the vulnerability. And basically, another thing that I wanted to show you is that we tried to think about attack ideas, attack surfaces. In kind of like the middle of the contest, we tried to think of attack vectors. So we thought about staking manipulations, about oracle manipulations, but there are no oracles. So maybe just to play with the ratio between the collateral token and the credit token, liquidations, create some kind of denial of service attacks on liquidations, front running, and these are all terms that you are familiar with, right? You went through these chapters in the smart contract hacking course. You learn about DOS attacks, about front running attacks. So now this is the time to apply your attacker mindset and see, okay, maybe I can do front running here. What if I front run the profits that are coming? What if there are liquidations? Maybe I can denial of service, make sure that no one can liquidate my position. Okay, maybe I can do a flash loan to manipulate the ratio between the collateral to the credit token. So this is when you're trying to apply your attacker mindset and think of all the potential state manipulations, attack vectors, and try to apply them to the code base, to the protocol, to the contest that you are participating in. And this is where we started thinking about front running, and Taz came up with this cool thing that we can front run this new profits that are being added. Yeah, okay. Yeah. So yeah, we just did this brainstorming and we thought about it, but Taz was the one that actually validated it and saw that it actually works and wrote a POC. And this is super cool. Like you can just front run this NotifyPnl call and either just steal the rewards from other users or just avoid slashing. And this is the POC that basically shows that new profit was added and you place your transaction before, or a new loss just happened. So you unstake before the loss is gonna slash your guild tokens or credit tokens. And this is beautiful. As you can see here, this is the print. There are no pending rewards initially. Then user 0 has pending rewards and user 2 has pending rewards.
Yeah, I know what's going on. User 2 is user 0 and 1 are like just regular stakers. They're not front running. User 2 front runs, and you can see that over time, user 2's profit rewards increases, and you can see that it has an extra 0 at the end, so it's 10 times more than user 0 and user 1.
This more 0, as you can see, because it just front run every time there is a new profit. It front runs, stake and unstake, and just get these rewards, which is cool. This one was medium. Taz, you want to explain why we marked it as medium? Because initially we wanted to report it as a high.
We just compared it with the documentation for C4Rena, and it said something like direct loss will be a high, but like stealing fees is a medium or something like that, wasn't it?
Yeah, I think so. So FYI, if there is direct loss either to users or protocol, then it's a high. If you just steal some rewards, I mean, it's questionable if this one is going to be high or medium, but we decided to report it as a medium. There is another front running that is possible in surplus guild minter. So it's based on a similar, what's the difference between them? I forgot.
I think this was on credit token. Can you scroll up to the introduction?
Yes.
User. Okay, user can stake and unstake front surplus scale minter. So this is a bug with the credit token. Same like attack idea, but instead we're doing it with the credit token here.
Yeah, so there are two staking mechanisms. You can either stake credit token for length term or stake guild tokens, right? And both of them can be taken advantage on when there is a new profit. So it's the same core issue. Maybe it will be accepted because it's like two vulnerable points in the system, two different contracts where you can stake and unstake. One time it's credit token, the other time is guild tokens, but in both places you make profit. So maybe these two ones will be considered as one, but we'll see. It will take some time for the judging.
I think it's two. It's two different contracts. One bug fix will not fix the other one.
Yeah, one bug fix will not fix the other one, but both of them are based on front running this NotifyPnl. But I think it will be considered also as two. Okay. Yeah, I hope that's clear, by the way, the explanations. If you have any questions, please let me know and ask them. We are here. We are listening to your chat messages. So yeah, you see, this is a concept that you know about front running. We just front run here. Profit or loss that's coming to the system to make profit on top of other users. Pretty straightforward. I mean, if we just go line by one through the POC, it will just take a lot of time because we basically maybe we'll give some tips about POCs of like how to write them better. Maybe Taz also can share a lot of tips because he was the one who wrote them mainly. I tried to write POCs, but my assumptions got disvalidated. We don't have a lot of time because there are other interesting attack vectors that I thought about, but eventually they were covered, they were secure. So eventually Taz was the one who wrote most of the POCs. It will take a lot of time if we go line by line because there is a lot of imports and dependencies, but we mainly, I will give you my tip, take the existing coverage tests and based on that, create your POC. So when I tried to write POC, I just went to the test contracts and added a new function. But what Taz did, he created a new file, completely new file for the POC with all the imports and everything. But obviously he copied it from the existing tests because there is the setup going on and it's a lot of setups. It's a lot of contracts that work with each other and interact with each other. And then a lot of setup happening over here, parameter setups and stuff. And the idea here is to show your exploit, to show how what you described over here is actually happening. So you set up the state and then you show that once you take these actions, the state is being changed to what you described, how you make profit, how you make the protocol stop rocking, how you make something happens, which is very similar to what you do in the smart contract hacking course. In the exercises, you are proving that some state is reached. You are writing a code, you are deploying a malicious contract, you are doing some transactions, and eventually you should reach some state. So this is just the same thing. You just want to reach the state and show how you reach the state, but by taking all those malicious actions. Taz, do you want to add some tips about writing POCs or like how you approach the POC findings?
Yes. I can tell how I approached this POC. The way I did was I would first write down the steps that you see above inside the markdown. So I would put something like that inside my comments for the POC file. And then I would start calling the functions that I want to call to make it work. And obviously it's going to fail at first. And you check the errors and you see that some condition has to be met. So you meet that condition inside the setup or somewhere and then call another function. The function is going to fail. You see why it fails, add more setups. Yeah, just rinse.
A lot of debugging back and forth, right? So you put your plan.
Also, at some point you're gonna get stuck. So I just imported Forge console inside the actual code, like the ECG code, and then just put console log everywhere, so I will know where it's failing.
Mm-hmm. Yeah, console log is very useful. You can import it both on the POC file, but sometimes you can also import it in the contract themselves if you want to print the state. Meanwhile, you do the calls. If something doesn't make sense, something doesn't work, or you want to see something while you execute the attack here, so you can add those console logs inside the contract themselves, which is very useful. I think they did use safe transfer. Sometimes it's an issue when you are dealing with a lot of ERC20 tokens, because some of them are not following the standard and they don't revert if the transfer failed, but they just return false. And that's the idea behind safe transfer. So if they return false, it will revert the transaction, something that we talk about in the course. But in that case, the transfers are happening with the credit tokens. So when they transfer credit tokens, they don't need to use safe transfer because they know that it reverts if the transfer fails and it doesn't return false. But when you deal with collateral tokens, yes, you need to use safe transfer. And I think because collateral tokens can be any token that is being added to the lengthy term. And I think in that case, they do use safe transfer form, if I remember correctly. If not, it's an issue. If there is a transfer of a collateral token and they don't use safe transfer, if the collateral token is not an ERC20 token, so it just returns false, it's a bad. No, we don't deploy. I mean, what do you mean? We don't deploy the whole contract for the POC. We just copy the setup from the existing test files. In that case, the test was the coverage was very big. All the contracts almost got tested. So you have all the setups. Sometimes you have exploits that are cross contracts. So the setup that you have currently is not good enough because you need to plug more contracts to showcase your POC. But usually the setups that they also had here was sufficient for us. So we just copy them and adjust them. Copy the existing test setups and adjust them for the POC. Adjust the parameters, maybe remove one contract that is not necessary, maybe add one more contract. So that's how it works with the POCs. I'm curious about the proof of concept you created in Foundry to showcase the front-running scenario. How did you manage to write a POC with Foundry, especially considering that Foundry isn't the feature-rich as Hardit? That's a very good question. How do you show front-running in Foundry? We don't. Because in Hardit, as you know, in the front-running exercises, we can simulate a front-running. We can simulate how because we have JavaScript, in Foundry, it's all in Solidity. I don't know how to simulate front-running in Foundry. That's why I think we don't have the exercises in Foundry, these particular exercises. But we didn't actually monitor the mempool and do the front-running. We assumed that someone is front-running the NotifyPnl. So we just call the NotifyPnl, and then we right after call the user stake, for instance. When it's a profit, so the user stakes. If it's a negative PNL, we just put the transaction of unstake before. And we assume that an attacker will be able to monitor the mempool and to place his transaction either before or after the monitored transaction. This is okay. You just write in the comments, here we front run this transaction, so we put the transaction before. You don't have to show how you actually do the front running here. Unlike in the course where we actually simulated it. Does it answer your question, Hashimed? So which was set up with Hardit and not Foundry. Would you have any tips of how to do smooth convert to the project to Foundry? There is a great article, I think that someone from the community wrote about converting projects from Hardit to Foundry. We won't get into that, do some research online, but there are ways to do that. Can't you use wrap in Foundry for surrender attack? I'm not sure. Actually, I'm not that pro in Foundry, but maybe Taz will know how to simulate front running. But it's a bit out of scope for this session, so I think better if we just move on with the next findings. Next one, we have this simpler one that we will leave the most juicy and the hardest one to the last one. But now we have the profit manager incorrect profit index initialization. There was some kind of math logical issue with the ways profits are being calculated, which we can use to trick the system.
Yeah, can you go over to Excalibur loan? It has the same equation, but it's easier to read. on the bottom left.
By the way, another one, as you can see here, we did some to-dos here. So we tracked our progress and the timeline. Just another FYI. This is another thing that helps us to manage our work and be synced. So we have here to-dos. Also, I asked some questions like the sponsor. So just took a screenshot from Discord and put it here. So yeah, you can really use Excalibur. It's very useful to collaborate on audits. Very, very useful both to create to-dos, diagrams, add screenshots. So next time you might try it out if you didn't. And now let's go back to loans. And where is it, Taz?
Should be on the bottom left. Yeah, see some colors next to the auction pricing.
And
zoom into the equation.
Profit manager, yeah.
Yep. So the way that the profit for a user is calculated is by these two equations. If you're familiar with the synthetic staking reward algorithm, it's basically the same idea. Let's just call it a reward accumulator. Let's just call it profit index. So as the code calls it that way. So you have two profit index, one for the gauge and one for the users. And to get the user credit reward, you would multiply the user shares, and then take the difference of the current gauge profit index and the last gauge profit index when the user did some kind of action. So this is how the reward is calculated. And again, it's the same as synthetic staking reward contract. And now maybe go back to the GitHub issue.
Sorry guys, just FYI. So as Taz mentioned, this is very similar to synthetic staking reward, which means that obviously in that case, Taz, this is finding an issue that Taz found that I understand it now, but I didn't have idea. It was hard for me to understand. Why? Because I'm not familiar with how synthetic staking rewards works, which basically means that the more you're familiar with more DeFi protocols, if it's staking, AMMs, lending protocols, the better you will become in auditing, because there are some concepts that are similar in other protocols, right? So that's what helped us, because he's familiar with synthetics. He saw that, okay, they implement the same mechanism, but they have an issue with the math, with the logic. So what comes out from that is like, go learn protocols, go learn issues, go learn how staking works in synthetics, how this works in MasterChef contract, how it works, because in the course we have a glimpse. We cover the most famous AMM, which is Uniswap. We cover the most famous lending protocols, Aave, Compound, a bit of Maker. Owen covers a bit of BFI Finance and other things. Also, you can go to Taz's channel, and also he has a great website, a smart contract programmer website, where you can learn other protocols like Curve, like Uniswap v3. So the more protocols you're familiar with, the more DeFi protocols you learn, the easier it becomes for you to understand these systems and find flaws in them, which what happened here, and this beautiful finding by Taz. Now, sorry for interrupting, Taz. Now, where are we going?
Go back to the GitHub issue.
To the GitHub issue, okay.
Yeah. Okay, so if I remember correctly, I think the issue was that user profit index was always initialized to this 1E18, but compared to like other...
Do you know where is it in the code? Maybe we'll jump to the code to showcase it. I think it was in the profit manager NotifyPnl.
Okay, yeah, sure.
Yeah, so profit manager. And you know what? I will go to your repo so we can see your audit comments.
If it's still there.
If it's still, it should be, I think, no? Git checkout as. Why? And git checkout dot. Git checkout Taz. Profit index.
Don't remember. Maybe search for profit index. Yeah.
Claim.
Should be somewhere in claim rewards. Okay. Yeah. I think this is it. So you can see that user profit index is initialized to 1E18 if it's not already initialized.
This one. Yeah.
Yeah. Yeah, but if you think about it, that means that if it's the first time that the user is claiming rewards, then you do the delta index and you get back all of the rewards minus the first 1E18.
Because you get all the gauge profit
it,
index minus 1E18.
Yeah.
Because it will be 0, then
Yes,
it will
exactly.
be 1E18.
Yeah.
Okay.
Yeah. So the trick was to call it twice, and then you'll be able to get all of the gauge profit index.
So you call this function twice, and then you get all the rewards basically because of this logical issue, right?
Yeah.
And what would be the fix?
I think it was something tricky. Can you go back to the GitHub issue? Something with initialization.
Yeah.
You need to initialize it in
Let's
a
go
correct
to the
way.
mitigation.
The first time that claim reward is called, it always hits this spot. So you can initialize the user profit index by setting it to the current gauge profit index. That's the solution.
Yeah. So I will try to simplify it. Imagine that the lending term is making profits. This is the gauge profit, the profit that's supposed to go to everyone. And now we want to check the delta based on how much users staked, how much is supposed to get based partially of this whole profit for everyone. And because this initialization issue, because we just put it this number, if we call this function twice, we're just gonna claim all the rewards from everyone. So instead, we need just to put the last index. So when we do this gauge profit index minus the last index, it won't be so much. The delta index won't be so much, because if this is going to be 1E18, the second time we call it, this delta is going to be huge because the gauge profit index just progress because there are more profits added to the system, and a big number minus IE18 will be big number. Delta index will be big, which means the user will get rewards that he's not supposed to get. But if the user gauge index in the first time that he stakes into the system will be the last gauge profit index, then if it will be the same minus same equals 0, which means that the user will not get rewards that he's not supposed to get. So this is basically the fix that was introduced here. And this is another high, because we can just call this function twice and still rewards that we are not supposed to get, right? Okay, moving on to the last one, which is a bit more complicated to explain because it's complex. It involves multiple contracts and AuctionHouse and the credit multiplier, which is like we have to explain what is credit multiplier in order to explain what is this issue and why it's problematic.
I can explain credit multiplier.
Yeah. Okay.
Credit multiplier gives discount for credit token. It starts out as 1, but if the lending term reports a loss, then credit token will be discounted, and it will always be it can never go back up to 1. Once it's discounted, it will stay at that level. And if there's another loss, then it will be discounted further.
So this is the credit multiplier. As we told you before, if you go over here to the lending and borrowing, the optimal scenario is that credit multiplier is 1. If credit multiplier is 1, you deposit 1 USDC and you get 1 GUSDC. But what happens when credit multiplier goes down? When it goes down, when there are losses in the system. When the lending term is losing, the credit multiplier might go down, never up, only down. Then for 1 USDC, you will get more GUSDC tokens. You will get maybe 1.1 GUSDC, maybe 2 GUSDC tokens, based on this credit multiplier parameter that is in all the contracts of the system. It's in the simple PSM, in the lending term, in the surplus guild minter. All the contracts are looking at this credit multiplier to see what is the ratio between the spec token to the credit token, and only one of them updates the credit multiplier when there is a loss, right? I think it's Profit Manager, if I'm not wrong.
Yeah.
Credit multiplier equals, so together, multiplier equals, This one. This is the only place in the whole protocol where credit multiplier is being updated. As you can see over here, new credit multiplier is being calculated and it's being set for the protocol. And now all the contracts are referring to this new credit multiplier. And as you can see, it can only go down because credit multiplier multiplied by the supply minus the loss divided by credit total supplies will always be lower than the previous value that it was before. This is what the math does. This is math. So now let's go back to the finding and let's try to explain it. Taz, the mic is yours.
Oh, okay. So imagine a scenario where a lending term has some kind of loan and it gets auctioned off. At the point the auction starts, the amount of credit that needs to be repaid is fixed. So let's say 100 credit. This auction asks the auction to...
Sorry for interrupting. There is any diagram where I can show meanwhile that it will be easier for them to understand because it's quite complex. Let's maybe go to the loan one. Yeah. So you have a loan that can be called, right? It's being called. It goes here to the AuctionHouse. Yeah. Now go ahead.
Okay. So let's say that it's asking for 100 credit. So the auction started, 100 credit is being asked. And let's also imagine that there's another lending term, not this one, another one. Another lending term reports a loss to notify profit manager. When notify profit manager is called for a loss, as we said earlier, the credit multiplier gets discounted. And then let's say that we're going back to this auction that has this auction, and someone bids to repay all of 100 credit. So this will go back to the call to function on bid.
Somewhere here in the beginning, someone wants to pay all the credit tokens, all the 100 credit tokens that required to cover the loan. Okay.
Yeah. And then go back to lending term on bid. If you look inside on bid, I think it's better to look inside the code.
Yeah.
Or on bid.
It fetches the credit multiplier.
It fetches the new credit multiplier. So this means that the amount of token that was repaid is now less than what it's supposed to get. So what we're saying here is even though the auction was successful without any loss, because the credit multiplier went down in the meantime, now this contract is saying that there's a loss. And even though this lending term was safely able to close the loan, it's now going to report a loss. And what this means is that surplus guild minter will be slashed for this lending term.
So a slash is happening.
And also another...
Go ahead.
Yeah, also another thing I want to mention is that, so in this scenario, we said that one of the bad lending terms reported a loss, so the credit multiplier went down. Next, the good lending term, the one that was able to safely close the loan, also reported a loss back to the profit manager. So it reported up loss twice, even though one of them was not supposed to really do that.
Mm-hmm. Yeah, so it's some kind of like, because this credit multiplier, if you think about it, it's a very complex state parameter because it's a state parameter that is mutual to all the contracts. So there could be multiple lending terms that this credit multiplier will be updated. And we thought, okay, what happens if meanwhile an auction, there is some kind of discrepancy and this credit multiplier is being changed? The auction started and then there is some time that passes, right? This time until someone calls the bid function to close the loan, to liquidate this position. And in this time, the credit multiplier, because there are so many places where it's being fetched and updated, what happens if it's being changed? And then we go to this on bid function. Yeah, so the credit multiplier was changed in the meanwhile because of another lending term did a problem and it had bad debt. But we reported the loss and then users got slashed, profit was cut, even though it's not supposed to cut, because we actually closed the loan in a good place, not late, but very early. All the credit got paid, but because this credit multiplier was updated meanwhile, and this time frame in between, the system is screwed. Like, users are getting screwed, and there are slashes happening even though they're not supposed to happen. Yeah, it's a bit complex one, but these are the most interesting ones, because if there are like cross contracts that are involved, right? And there are also two lending terms contracts that are like, what happens when two lending term contracts, their state is moving with each other. This is where you find these unique findings. I hope this one will be unique. I think it is a unique, and this will be like the best one, because I don't think many people thought about it. Maybe there will be other unique ones, but this one, because it's more complex, it involves a lot of contract and state changes between contracts. It might be more unique, but I say it every contest, and then there are 100 duplicates for the finding that I think that is unique. So we will see. Only time will say. Yeah, but this was the last finding that we reported, as you can see. And yeah, that was it. I hope you guys enjoyed it. Any questions, guys? Anyone want to share his findings? Maybe you want to ask questions about these findings that we shared with you. So the credit multiplier is global. Yes. The credit multiplier is global per credit token. Credit token can have multiple lending terms, right? And credit multiplier is being changed across all these lending terms. Anytime this one lending term is reporting a loss, this credit multiplier is being decreased, which means the ratio between the PEG token to the credit token is being changed. More credit tokens are being offered as a discount. Oh, DOS on auction mechanism if a borrower is blacklisted. Let's try to think. So there is an auction. Someone is paying the collateral. Someone is paying the credit to get the collateral. The collateral is in the smart contract. So no, it doesn't matter. If the borrower is not in the picture, the collateral is already in the smart contract. Someone is offering to give credit tokens to the system, to the lending term contract, to the system, to get those collaterals that are already locked in the lending term contract. So the borrower is not relevant anymore. It's not a valid finding, EVDoc. On bid will revert when trying to... Oh, yeah, this is actually interesting. Yeah, because part of the collateral is being paid back to the borrower. And if the borrower is like in blacklisted, I think it's a valid finding, actually. Taz, what do you think? Did you follow the flow?
Yeah. I think it's a good idea. I think it's up to the judge to decide, though. Yeah, I think it's a really good idea, though.
Yeah, it's a very good idea, but the likelihood, I think, is very low, guys, because you cannot do something actively to DOS your position from getting liquidated. This is another idea that I thought, okay, how do I make sure no one can liquidate me? No one can call my loan. Is there any way to do that? And what you just described is a very good way to do that, but you cannot do it. You cannot blacklist yourself in USDC and USDT. And if you will do it, yes, you will screw the users that they cannot liquidate your loan, or screw the protocol, but you also screw yourself because you are blacklisted. And you cannot really do that. Maybe there is a way to forcefully add yourself to blacklisted, but I'm not sure. Lending term can be drained if collateral is CUSDC v3. Wait, let's see. I will go to the Hashimen first. Let's see. ERC rebase is at line 585. The return value success from ERC 24 isn't checked. We just returns it. Yes, because okay, it doesn't need to be checked because the credit token is the rebasing token, so it's always going to revert if a transfer fails. So anytime we transfer credit tokens, we don't need to use safe transfer form. It's possible, but it's not going to create a real bug in the system. You cannot really use it because we know that credit tokens reverts if a transfer fails. If you can see a transfer of collateral token without check of the Boolean or safe transfer library, then it's a problem. What about this one? Lending term can be drained if collateral is CUSDC v3. If collateral is CUSDC v and amount in is type uint max, then Only the available balance of CUSDC v3 will be transferred as collateral, but type max will be counted. Okay, I'm not familiar with CUSDC v3 with Curve, to be honest. Maybe Taz can shed some light on that. Or maybe you can take the mic.
CUSDC.
Yeah. Maybe Evidoc, you want to take the mic and explain it, maybe? CUSDC v3, I think it's Curve.
I understand what he means.
I think it's Curve, right? Evidoc? Yeah. Or maybe Compound. Curve or Compound? Just write Curve or Compound. Okay, you can speak, by the way, if you want.
I think...
Yeah,
hey, guys.
Hey.
Yeah.
Hello.
Because when you try to transfer type UN256 max on CUSDC v3, only the available balance of the sender is sent. But in this case, in the system, it will be accounted like if type UN256 that max is sent. This is specific to CUSDC v3 contract.
Okay, so how do you explain it? Yeah, go ahead, Taz.
That's a good idea, but I think it'll be rejected because I think they'll say something like before CUSDC gets onboarded, it will go through the review process and it will be rejected by the governance.
Yeah, so that's the thing with when you have governance or like access control, everything regarding like weird stuff that governance need to accept might be disvalidated. That's what I learned from previous context. A lot of findings that I submitted, they just got disvalidated because the sponsors say the governance will not accept this token, which is actually, I don't agree with that, because a lot of attacks that we see actually out in the space is because some governance action, weird action was proposed, or something went below like governance scout, or maybe the multi-sig wallet got compromised, and then because it had a lot of rights that could be restricted more, the protocol got hacked and the money got drained. But this is how it works in auditing contest. That's the difference. When you're in auditing contest, you usually don't spend your time reporting these issues because you're not going to be rewarded. You can, but you will just spend your time. It will be ignored. But if it would be a private audit or audit that you provide to a company, it's very like important to mention this to the protocol because, yeah, that's my take on that.
Yeah, it makes sense. Thank you.
Sure. So if you see a lot of places where there is like function is protected by governor, I always like write audit okay, out of scope, because I know that anything that I will say about this function, they will say, governance will not call it, or like, oh yeah, the admin will not call it, or the admin will not do that, or like address zero checks. Yeah, the admin will check. He has its own tool that makes sure that he doesn't pass address zeros to functions. So that's why I don't spend my times anymore of like submitting those issues or looking for these issues. And as you can see, we looked for more interesting ones, issues that can be generalized, right? So anyone could front run these functions. Anyone could just call this function twice and make this profit. There is a bug in the system with the credit multiplier that causes losses to users without that it's not supposed to happen. These are like broad issues that anyone either can exploit or bugs that will hurt the system anyhow. These are probably going to be valid, I think, I hope. And hope there are not going to be many duplicates. Other questions, guys? Anyone else want to share his findings?
Okay. I have two more findings. Maybe I can share them quickly.
Sure, go ahead.
It's about opening fee. I think that it must be charged once. But it's charged on each partial repayment.
Ooh, this
because
is interesting.
You can take a look at get loan debt functions.
You know what? Wait, I'll show my screen again. Let's see. We missed that. Let's see. So in which function?
Get loan debt. This function is called on partial repayment.
Yes.
And it computes opening fee for each partial repayment. And I think that opening fee must be charged only once on the initial borrow amount.
Yes, that makes sense. Wait, let me think. So opening fee, every time we call partial repayment, this function will be called to calculate that. And in the first payment, the opening fee will be paid because it will be included. And then they need to mark somehow that this opening fee was paid already. They don't change it to zero. Or, I don't know, they don't mark that the user already paid the opening fee. So it makes sense. Do you have a POC that shows that? That user is like paying twice and it pays too much?
Yeah, maybe I have a POC. Give me just 1 minute.
Yeah, this is a very nice one. What do you think, Taz?
Yeah, it's a nice one.
I think it's a medium.
Need to look at the documents on what they mean by opening fee, though. Is it for fee charge? Does it, if it says fee always charged on repayment or not?
Yeah, so you need to look at the docs, like what is exactly opening fee. Maybe it's intentional, right? A lot of things that that's also happened to us, a lot of things that we found out, we're like, okay, it's intentional. Or sometimes we even validated with the sponsor. You can also ask the sponsor, but you might, I don't know, some people prefer not to do that. Oh, you have a POC, nice. Prepare, borrow, partial repay. Check. Oh, so you basically pay and you show that you're supposed to, in the second time, you're supposed to pay more than you actually are supposed to pay, right?
Yep.
Yeah, cool. So this is probably a legit one, but again, it depends on what they write on the docs about opening fee. Nice one. Any more? The other one you wanted to share?
Yeah, it's about the forgive function. You can find this function in the auction contract and also in the lending term contract. The problem is that if the governor forgives a loan that is on auction, he won't be able to change the auction house because the forgive function in lending term does not decrement n auctions in progress. And if n auctions in progress is not equal to zero, you're not able to change the auction house. I don't know if it's here. I have a POC for this one also.
So, okay, governor calls the forgive function in the lending term, and what does it do? And for like a loan that is actually in the auction house right now, what will be the results?
In this case, he won't be able to change the auction house by calling the set auction house function because
set auction house.
Because the state variable n auction in progress will be equal to 1.
Always, because there is an auction that never ended, right?
Yes.
So he basically is going to break the whole auction house contract.
Yes.
So if a governor calls forgive function when there is a pending auction, ongoing auction, he basically breaks, but he only breaks this set auction house function, right? He cannot change it.
Yes.
Interesting. I think it's a low because the likelihood of this happening is low because they can say the governor will not call forgive for open loans, and also they can say that the likelihood is low, but the impact I think is quite high because if you cannot update the auction house, it's not very high because it just means that you cannot update the auction house contract. But it's kind of like you break some kind of functionality of the protocol if you make this mistake. But again, it's
you will have to board maybe the landing term.
Yeah, you will have to replace the landing term, but you can do that because you can just deprecate this landing term and deploy a new one and onboard a new one with a new implementation, right?
Yes.
So I think it's a valid low, to be honest. But again, the judge will say, but it makes sense. Did you report it as high?
As medium, this one.
Medium.
Fingers crossed.
Fingers crossed. Maybe you will get a medium, but I think they will either say it's out of scope because it's governor function or a low. But let's see.
Let's see.
Okay. Any more questions, findings, guys? Okay, I guess then that's it. Thank you so much first, Taz, for putting the time. It was awesome working with you and in the contest, and also doing this live stream and to do this mutual class together. I really enjoyed it. And thank you everyone for joining. Really, it was a great pleasure both to show you what we did and to hear your thoughts and answer your questions. I really enjoyed it. I hope you too, Taz.
Yeah, I did. Yeah, it was fun working with you and this live stream as well.
Yeah. Okay. So thank you so much, guys. If you didn't do the final exam of the course, you can do that already, but read all the instructions before. And we're preparing some perks for this certificate. So first of all, it's cool that you have it. You can showcase it on your LinkedIn, on Twitter, and take the exam. It's fun. If you've been through all the materials of the course, you're supposed to pass it and maybe even get the excellent certificate. And if not, just you have the course. Just go through the materials, do the exercises. And remember, step by step, contest by contest, and that's how we get better. Thank you so much for coming, and I will see you in the next one. And by the way, subscribe to Smart Contract Programmer if you didn't already. Great content, great videos, great explanations. Go check out his website if you want the practical exercise vibe. So for almost every video that he publishes, he has the website where you can actually code it, like live codes, write Solidity code and play with Uniswap protocol and play with synthetics and Curve, or like some DeFi protocols and some attack exercises. So it's super cool. Check out his channel and the website. And yeah, maybe we'll do more of this. It was pretty fun. Thank you so much, guys. Thank you, Taz, again.
Yeah.
And bye-bye.